let's find the relative extrema, maxes or mins. Make a table, find the intervals of increasing, decreasing. First thing, find the derivative. And you might want to rewrite this as 4 minus x squared to the 1/2. When you derive that, you put the 1/2 out front, leave 4 minus x squared, drop the power by 1, and then derive the inside, which would be negative 2x. There's your derivative. Now, you set your derivative. Actually, let's clean up your derivative. It looks like you're going to get negative 2x over 2 square root 4 minus x squared. Which won't those cancel? So we now set our top equal to 0 and our bottom equal to 0 for critical numbers. Oh, sorry, this is negative x. But does that change anything? No. So there's one critical number. When you do this one, don't you square both sides? And then when you solve this, don't you get x equals positive or negative 2? Those are your critical numbers. Now, before we go any farther, those are your critical numbers. This one actually has domain restrictions. If you think of this, doesn't the 4 minus x squared have to stay positive? Doesn't that have to be greater than 0? Sorry, greater than or equal to 0? Doesn't the inside have to be stay greater than or equal to 0? So there's some restrictions to this problem. If we solve this, you end up with negative x squared is greater than or equal to negative 4, which when you divide by negative 1, sign flips. When you square root both sides, you end up with x has to be less than or equal to positive negative 4, which doesn't make sense. But it's still, let's do something different here. Let's move this over. X squared minus 4. You guys okay with that? But it's still the same thing. X has to be less than or equal to positive or negative 2, which doesn't make sense. I messed something up here. Because when you solve it, x squared, you square root plus or minus 2. Anyways, it has to be between negative 2 and 2. You guys okay with that? I don't think with inequalities, if you square root both sides, there's a situation like with the remember absolute value, you had a change the second sign and so forth. Because this right here is saying something different. This is not it. But when you look at this, when would this be less than 0? It would be, your answers would have to be on this interval. Are you okay with that? Because when you solve this, you have x. This is stupid. I'm having a lot of problems today. It's going to be between these two intervals. You guys okay with that? When you solve this, it's going to be in this interval. It's not just this up here. So, when you make your table, it's basically this. From negative 2 to 0, and from 0 to 2. You okay with that? Now, you don't have to check the endpoints because there's nothing on the edges to check the other side. So let's plug in something to the derivative. Let's plug in negative 1 here. Let's plug in 1 here. When you do that, when you plug negative 1 into the derivative, what'd you guys get? Let's see. When you plug it negative 1 over the square root of 4 minus negative 1 squared, which ends up being 1 over square root 3, which, isn't that positive? So isn't that increasing? When you plug in this one, the opposite of 1 over the square root of 4 minus 1 squared. This one's negative, so this is decreasing. So we're increasing into decreasing. This is 0. When you plug 0 back into the original, g of 0 would be the square root of 4 minus 0 squared, which would be 2. So 0, 2. And what is 0, 2? A max or min? Well, if it's going from increasing to decreasing, that means it's a relative max. So 0, 2 would be relative max. You don't have to worry about the endpoints that are critical numbers because they're at the ends. You can't check both sides.